All right, guys. As we discussed in the previous videos, we're going to talk about some rules about horizontal asymptotes in this video. As you can see, f of x is indicating the regular form of the rational functions. And you have polynomial functions on numerator and polynomial functions on denominators. And as you can see, the highest degree, which is the leading degree on the numerator polynomial, is nth degree right here. And the highest degree on the denominator polynomials is mth degree here. So then we will look at some cases, how it can verify different cases by how we observe the degrees on each side, top and bottom. First case, n is less than m. The degree of the numerator polynomial is smaller than the degree of the denominator polynomial. Then the result in x-axis is the horizontal asymptote. In other words, the horizontal asymptote will be y equals to 0. Okay? Then, second case is when the degree of the numerator polynomial is the same with the degree of the denominator polynomial. So n and m, the highest degree of each side, is exactly same. Then horizontal asymptote is the line where y equals the leading coefficient of the numerator polynomial over the leading coefficient of the leading term of the denominator polynomial. So then simply you can find the leading coefficient from the top stays top, leading coefficient from the bottom stays bottom. Then the third case, n is greater than m. Then that means we have greater highest degree on top and the highest degree on the denominator's polynomial is smaller than the degree on top. So then we can expect the horizontal asymptote is not gonna be applicable for this case. Instead, horizontal line, we will have slant asymptote, slant, diagonal, oblique, all the same meaning. So it's not going to be horizontal. It's going to be slanted. Okay, so then I mentioned top heavy and bottom heavy in last week's videos. Then as you can see, we can verify each cases with that description here. What about the first case? It's n is smaller than m. That could be verified as bottom heavy. So bottom degree is greater than the top. Then what about this? N is greater than M. Of course, we can call it top heavy because the leading degree on the numerator, the top side, is greater than the bottom. Then N equals to M means the numerator polynomial has the same degree with the denominator's polynomial. Then we will figure out our horizontal asymptote with the leading coefficient from each side. So among these three, we will start to look at examples for each cases. Then let's see which case the next example would be. Find the horizontal asymptote for f of x. 4x squared minus 3x plus 1 over 2x squared minus 1. And I told you guys to factor first to figure out. Of course, you have to do the procedure one by one in order to complete graphing and finding key features. But what I want to focus on this video is observing the three cases, how it determines the horizontal asymptote separately. So not necessarily we will go through whole procedures to complete the graphing, find the key features. We'll only practice how three different cases will make you find the proper horizontal asymptotes only. Okay, so don't worry about factoring each side first. We will focus on the leading degree of numerator and denominator first. Then what do you see? What is the highest degree of the numerator? It's x squared is the leading term, and x squared is also the leading term of the denominator. Then this must be the case of the same degree top and bottom. Then when we have exactly same degree from top and bottom, then we can figure the horizontal asymptote by looking at the coefficient of each leading terms. So I don't really have to look at all the other terms. All I need is the coefficient of the highest degree of each side. Then in this case, we can cancel everything and simplify. 4 divided by 2 will be 2. Then it will lead you to have horizontal asymptote at y equals 2. So, okay. So then let's take a look at the second example. Find the horizontal asymptote of f of x equals x squared minus x minus 6 over x squared minus 1. Again, if we're supposed to complete the whole graph and find the key features accordingly, I would go ahead and factor x squared minus x minus 6. So probably we will find two numbers multiplied to be negative 6 and added to be negative 1. And notice this one as the difference of squares, x squared minus 1 squared. So I can factor each side and verify the same factor top and bottom to cancel and so on. But before we move on, let's master how to verify the horizontal asymptote first. So, as I already highlighted the term from top and bottom in yellow, this is the highest degree from the numerator. This is the highest degree on denominator. They happen to be the same. Then now I can look at each leading terms from each side, top and bottom. Then now I can observe the leading coefficient 1 on top, leading coefficient 1 on the bottom. That gives you 1. Then you can say the horizontal asymptote will be the line y equals 1. It's a horizontal line passed through positive y value 1. Then before you figure out the vertical asymptote and then everything else, what you can start is with x-axis. Sorry. Okay. I accidentally hit the button and then it just went ahead. Okay. Then let's go back to this story. So then, if you start graphing it and y-axis and x-axis, and then you can draw the horizontal asymptote that you just found. It's y equals 1, and then it's going to pass through this level. Then you will find the vertical asymptote from the denominators, and probably this one will be parenthesis x plus 1, parenthesis x minus 1. That gives you the roots 1 and negative 1, and then here you can tell there's gonna be vertical asymptote pass through positive 1x coordinate and negative 1x coordinate, and then you can find the curves accordingly to each section and so on. But at least we can find horizontal asymptote by looking at leading terms from each side first, okay? So then let's move on to the next one. Okay, now I have rational functions goes 2x over x squared minus 5x minus 3. Then again, in order to figure out the horizontal asymptote, I have to focus on the leading term of each side. 2x is the only term on the numerator side, then this will work as the leading term. So the degree of the leading term from numerator is 1. Then the degree of the leading term from the denominator is 2. So 1 on top, 2 on the bottom. Then we can figure the case with bottom heavy. So what was the bottom heavy rational functions horizontal asymptote earlier? If we have bottom heavy, what kind of horizontal asymptote are we supposed to have? You remember? We can remember with this here. The leading term from the top is 2x. Leading term from the bottom is x squared. Then once you look at this way, and if you look at it, we're supposed to divide the numerator by the denominator. But in this case, obviously, it gives you the idea the denominator goes into the numerator 0 times. It cannot go in there because the bottom, which is the divisor, is the greater than the top, which is the dividend, right? So then with this, you can remember horizontal asymptote is the line y equals 0. Now, in other words, it's going to be just x-axis. So remember, bottom heavy, you can still compare the leading term from each side. And if just in case if you don't remember, and obviously you can look at the structure and it will remind you 0 because the denominator can go into the numerator 0 times. Then you can remember the x-axis will be the horizontal asymptote here. Yeah? Okay, then let's move on to the next one. Then, what about this one? Rational function is 3x cubed plus 2 over x squared minus x minus 7. Okay. With the leading term from the numerator, 3, and the leading term, leading degree from the denominator, 2, then now we can see this is the case of top heavy. The degree of the numerator is greater than the bottom. Then from the previous slides, we remember with the top heavy cases, we're supposed to have the slant asymptote. Slant asymptote. right? Okay, then that we remember this. Look at the leading term from top, leading term from the bottom, and you can directly compare them. But in this case, in this case, the mathematical instincts will tell you the dividend, the top, is greater degree, then the divisor is smaller degree. It's definitely divisible. Like as a mathematician, if you have this and you just have this tingly sense that you just have to divide the top by the denominators, right? Then what method can we use to divide the top by denominator? And here, we're not only dealing with the leading terms. If I want to divide this whole fraction, then I have to use all the terms from each side, and you have to do the long division method. So if I can remind you of the long division would look like this. The numerator will be inside as a dividend, and denominator will be outside of this notation, and then it's divisor, right? Then notice we will use placeholder as the descendant order of the degree here. 3x cubed, 3x cubed. But notice they skipped the x squared term and x term before you get to 2. So you do have to have the placeholder with 0x squared plus 0x. And the divisor will be x squared minus x minus 7 and outside. Then now, on first term on top will be the factor that would multiply x squared to be matched with the original term. So then with x squared, you have to multiply it by 3x so that you can have 3x cubed down here, right? Then once you have this, and then you have to multiply each term in order. So negative x will multiply 3x, and then it's going to be negative 3x squared. Negative 7 times 3x will be negative 21x. But once you come up with these terms, then you have to protect all three terms with the parenthesis. Now you have to subtract it. So then positive 3x cubed will be negative, negative 3x squared will be positive, and then negative 21x will be positive later. So then this will be canceled, and 0x squared plus 3x will be 3x squared. Then now it was supposed to be 0x plus 21 and 21x down here. But I just didn't go through all the way in order to have remainder or the final result. And then I just say yada, 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 like that. Because once you have 3x squared here, and this will match the same degree of the leading term of the divisor there, so it's square and then square, then with this, you can figure out the next term will be just numerical term without any additional x, because only the 3 multiplies x squared to match 3x squared down here so that you can cancel, right? Then this is all you have to go as further as you go, because 3x minus 3 on top as a quotient of this division will be this length asymptote equation by setting up with y equals. So 3x plus 3 equals to y, is you can recognize it's y equals mx plus b form. So then this is a slope and this is y-intercept. So then if you draw the linear equation of this y equals 3x plus 3 on the quadrant, this will be the graph of this, in which works as the slant asymptote. First, you will plot y-intercept 1, 2, 3. Then 3 in front of x is the slope, and it's 3 over 1. So then it goes 1 to the right, 3 up. Then you can draw this slant line pass through these two plots. Then now, with this slant asymptote, you will have another asymptote going on. Then you can figure out the curve in other area and so on. Okay. But since we have some special situation these days, I would not go too deep with this slant asymptote cases. As long as you can recognize what kind of function gets you the slant asymptote and what kind of curve that you will get based on that, and then I think that's all you need to know for this level. So don't worry too much about it, and you will see some exercise problems in separate worksheets with answer key. Then in those worksheets, and then you will see some problems that you will figure out some slant asymptotes and so on. So only the level of the problems that you will see on the practice sheets, and it's gonna be just assessed in next week's quiz. So with this video and the practice sheets that I uploaded right next to this video, and I hope you get a little bit better understanding about this horizontal asymptote. Okay? So that's all for horizontal asymptote rules in this video. Bye.